Hello guys, in this video tutorial I would like to explain different types of events and probability theory. This lecture is very important for all those who would like to study probability, because you can have different events and maybe in question and GRE and other such type of exam you will have this type of questions about different events. So if you know about these events, you can solve the problem. So this lecture will provide different types of events with their examples. And this is lecture 2 of the series of the probability. So let's move to the lecture. Okay, so we'll start from the simple event, the definition of the simple event. What is meant by a simple event? A simple event is one that can only happen in one way, or in other words, it has a single outcome. Maybe you know that from the first lecture that the outcome of an experiment, because we defined there that what is meant by the outcome of an experiment. I will explain once again here that what is meant by the outcome of an experiment. So the simple event is the event which has a single outcome. So remember this, I will explain this in the example. Compound event. Compound event is an event which has more than one outcome. Another way to view compound event is a combination of two or more simple events. So this is simply when you know that a simple event is the event which has a single outcome of an experiment, then the compound event has more than one single outcome, or you can say that this is the combination of one or more, of two or more simple events. Simple events of course has one single outcome. So let's have an experiment now. So this is the experiment below that. S is equal to this is we suppose coin toss two coins, then this is the sample space that most probably will have head on first tail and head on second tail, and probably we can get head on the first tail, first coin, and tail on the second coin, and probably we can get tail on the first coin and head on the second coin, and probably we can get tail on each coins. So a simple event in this case can be, we can take only single outcome in an event, then that is called a simple event. Like simple event, let's suppose A is equal to H mean that the single outcomes, these are the outcomes. If you don't know from the previous lecture, these are the outcome. The first outcome is H, second outcome is HT, the third outcome is TH, and the fourth outcome is TT. So simple event has, as we can see in the definition, that it has a single outcome. So you can take any single outcome from this the outcome of this experiment, and you can say this is simple event. Like A is a simple event which has single outcome, B is a simple event which has single outcome. Now compound event which has more than one outcome. So you can take two outcome up from them, or you can take all outcome. So then that make a compound event, and you can see that in the definition that a compound event is a combination of two or more simple events. So okay, you can combine these two as well to make a compound event. So compound event, so simply we can say that simple event is an event which has single outcome, and compound event as an event which has more than single outcome. So this can be the combination of simple event as well, more than two or more than two simple events. Okay, now the important concept is let's move to the independent events. Independent and dependent. Beside independent event, I discussed as I would like to discuss dependent event as well to make clear the differences. Independent events occur when one event remains unaffected by the occurrence of the other event. You can define this that independent event or the events where the probability of occurrence of one event is not affected by the probability of occurrence of the other events. So the same definition, but the wording is different. You can see the examples are, if we take two separate coins and flip them, then the occurrence of head or tails on both the coin are independent of each other. Of course, there are two coins, so whatever the outcome, they are independent of each other. So this is the example, and you can make other example as well. Dependent event. When two events are dependent, the occurrence of one event influences the probability of occurrence of another event. So this is just the opposite to the independent event. In the independent event, we say that the occurrence of one event is not affected by the occurrence of another event. Here we say that the occurrence of one event influences the probability of occurrence of another event. So the examples are not paying your power bills on time and having your power cut off. This is simple example. If you're not paying the power bill on the time, your power will be cut off. So this is simple example that power cut off dependent event on not paying bill on the time. Being the first person to enter a movie theater and finding a good seat. Second example is being the first person to enter a movie theater and finding the good seat. Of course, you can get a good seat if you enter the first few person to the movie theater. So this is also dependent event. Third example is, suppose that you want to have a queen with the first draw a card. The chances of getting a queen are 4 out of 52 cards. If we get a queen in the first draw, then the probability of getting a queen in the second draw will be 3 out of 51 cards, because in the 4 queens we got one queen, so the 4 remain 3, and total cards are 52, so one is drawn, the remaining are 51. So for the second draw, the total cards are 51 and queens are 3. Thus, these are said to be dependent events, since the probability of the second event depend on the outcome of the first draw. So just look at the definition and you will see that the events are dependent. Just you can see again the definition. The occurrence of one event influences the probability of occurrence of another event. So this is, of course, the third one is also a detailed example that the probability of the second draw is affected by the first draw. So you can see these are the different examples of dependent events, and the above is about independent event. Mutually exclusive event and not mutually exclusive events. These are very important definitions, and maybe you can see this when you are dealing with the probability. Mutually exclusive event. Mutually exclusive event can simply be defined as a situation when two events cannot occur at the same time. A mutually exclusive events can simply be defined as a situation when two events cannot occur at the same time. An example of mutually exclusive event is when a coin is tossed and there are two events that can occur, either it will be head or tail. Hence, both the events are mutually exclusive. They cannot occur together. So this means that they are mutually exclusive events. You can make a lot of example, success and failure, and you can make another example from the real life as well. Not mutually exclusive event. So this is the opposite to the mutually exclusive event. A not mutually exclusive event can simply be defined as the situation when two events can occur at the same time. You can see there is only difference. Cannot occur in the mutually exclusive event like here, and this is can occur at the same time. So this means that in not mutually exclusive may occur at the same time. Both can occur at the same time together. Examples are driving and listening to the radio, even numbers and prime numbers on a die, losing a game and scoring, or running and sweating. So these are the examples which can occur at the same time. So this is very clear about that with the example that what is mutually exclusive and what are not mutually exclusive. Impossible event, and on this slide we will discuss about impossible event and sure event. An event impossible event. Let's define the first the impossible event. An event which has chances of happening, the probability of such an event is likely to be zero. An event which has chances of this should be which has no chances of happening. So this should be corrected. This is wrong. The pro An event which has no chances. This should be corrected. An event which has no chances of happening, the probability of such event is likely to be zero. Okay, so this is impossible event. Isn't it clear from the name that it cannot be occurred? An example of an impossible event will be getting a number greater than 6 when a die is rolled. So this is simple example, and you can make other example from the real life. When you roll a die and you are expecting a number greater than 6, that is impossible event. It will not happen. So the probability is 0. Now sure event, an event whose chances of happening is 100% is called a sure event. This is sometimes called certain event, sure event, and maybe other names, but the definition is same. An event whose chances of happening is 100% is called sure event. The probability of such an event is 1. Of course, that's probability is sure probability. So now example, it is a sure event to obtain a number between 1 and 6 when rolling an ordinary die. Okay, so this is example. When you are rolling a die, you can get a number from 1 to 6. This is sure, you will get a one number from 1 to 6. So the probability of sure event has the value of 1. Now exhaustive event. Exhaustive events if in probability theory and logic, a set of event is jointly or collectively exhaustive if at least one of the event must occur. Okay, so in probability theory and logic, we can say that an event, a set of events is jointly or collectively exhaustive if at least one of the event must occur. Okay, if we have many events and at least one of them occur, then you can say those all events are mutually or jointly or collectively exhaustive. It will be more clear from the example. Let's see the examples. When throwing an unbiased six-sided die, the outcomes are 1, 2, 3, 4, 5, and 6 are collectively exhaustive. Similarly, when a coin is tossed, the outcome can either be heads or tail. Okay, so look at the definition of exhaustive events, and then you can see examples, so it's more clear. In probability theory and logic, a set of events is jointly or collectively exhaustive if at least one of the event must occur. Okay, so this is the definition there. The set of events, one must occur. Look now the example. When throwing an unbiased six-sided die, the outcomes are 1, 2, 3, 4, 5, and 6 are collectively exhaustive. Why? Because we can get one number between from 1 to 6. So at least one event is occurring. This means that these events are collectively exhaustive. Similarly, when a coin is tossed, the outcomes can either be heads or tails. So when coin is tossed, you can get head or tail. So at least one of these events occur. So this means that these events are collectively exhaustive. Equally likely events. When the outcome of an experiment are equally likely to happen, then they are called equally likely events. Like during a coin toss, you are equally likely to get heads and tails. So equally likely events are those when you are performing an experiment and the outcome are equally likely to happen. They are called equally likely events. And when you are tossing an unbiased coin, remember unbiased is important here. When you are tossing an unbiased coin, you can get head or tail equally likely. So these are called equally likely events. Okay, this is this in this video we explain different types of events with the example. I hope you will like this. In the next video, we will talk about Venn diagram to explain the different events, and then we will move to the rules of probability, difference of probability. So thank you very much for